Notice in these examples, L'Hopital's rule cannot be used immediately because we don't yet have an indeterminate form to begin with, but sometimes we can tweak the original function and write it in a way that does generate an indeterminate form. So for example, let's rewrite this limit as x approaches infinity of sine of pi over x divided by 1 over x. We're rewriting the function instead of x times the sine function. We have the sine divided by the reciprocal of x. Now we have an indeterminate form, which means we can use L'Hopital's rule. The limit as x approaches infinity of the derivative of sine of pi over x is cosine of pi over x times the derivative of pi over x, which is negative pi over x squared. And then the derivative of the denominator, 1 over x, is negative 1 over x squared. Now rewriting this, we can simplify it a little bit. Limit as x approaches infinity of cosine of pi over x times pi. Now we can actually evaluate the limit. As x gets really big, as x goes to infinity, the fraction goes to 0. The cosine of 0 is 1. So we basically have 1 times pi, which is pi. In this example, again, right away, we do not have an indeterminate form. But let's see if we can rewrite it in a manner that will give us an indeterminate form. Limit as x approaches 0 of, let's rewrite cosecant as 1 over sine x, and let's rewrite cotangent as cosine x over sine x. Now when we simplify the function here, we have the limit as x approaches 0 of 1 minus cosine x over sine x. This is now an indeterminate form, so we can use L'Hopital's rule. Take the derivative of the numerator and the denominator. So the derivative of the numerator, 1 minus cosine x, becomes sine x. The derivative of the denominator, sine x, we get cosine x. And now substitute in our 0, and we get 0.